In level 4, we're going to be solving more trig equations, but just a little more complicated. We might see some in quadratic form or just trickier equations. In this first example, we are looking for angles from 0 to 2 pi, so on the unit circle. And this is this equation is in quadratic form. And if I were to solve an equation like 2x squared minus 7x plus 3 equals 0, I would solve it by factoring. This is basically that same equation, but instead of x squared, we have cosine of x squared. So to solve this equation, I can first think about how to factor this equation. This would be 2x and x, and we would put a 3 here and a 1 here and a minus and a minus. And we're going to solve this cosine equation the same way. We're going to factor it, and we get 2 cosine x times cosine x, and then a minus 1 and a minus 3. Now, when we solve by factoring, we set each part equal to 0, and so we end up with two little equations that we have to solve. So first I do 2 cosine x minus 1 equals 0, and I solve this first equation. I add 1 to both sides. I get 2 cosine x equals 1, divide by 2, cosine x equals 1/2. So I want to think of all the angles between 0 and pi where I have a cosine value or an x-coordinate of positive 1/2. That would be x equals pi over 3 or x equals 5 pi over 3. Those are the two angles with an x-coordinate of 1/2. So those are two of my solutions to this equation, and now I solve the other side and see if I get any more. So I do cosine x minus 3 equals 0. And I add 3 to both sides, and we get cosine x equals 3. Now, I can't think of anywhere on the unit circle where I get a cosine value of 3, or an x-coordinate of 3. In fact, the range for cosine is between -1 and 1. If you think about the graph for cosine of x, which looks like this, it oscillates between 1 and -1. So its range is 1 to -1. It's never going to equal 3. So if I don't have a cosine or a sine value between -1 and 1, that's going to be no solution. So this part doesn't have any solutions, and my only solution to this equation are the first two I found, pi over 3 and 5 pi over 3. This next example is similar. Feel free to pause me and try it yourself. If not, what we would do is get everything to one side, set it equal to 0, and solve. If you're more comfortable factoring x squared equals 2x plus 3 first, feel free. But I'm just going to go straight to this trig equation. First I'm going to get everything to one side, and we get sine squared x minus 2 sine of x, and then it should be minus 3 equals 0. And now I factor. And we get sine of x and sine of x for our first terms. And we need a 3 and a 1, a minus in front of the 3, a plus in front of the 1. And now we solve each side of the equation. So our first equation is sine of x minus 3 equals 0. Add 3 to both sides, and we get sine of x equals 3. Again, just like a cosine function, the range of the sine function is between -1 and 1. So I will never have a sine value of 3. This part is no solution. So I see if I get solutions from my other side. Sine of x plus 1 equals 0. Subtract 1 from both sides, and we get sine of x equals -1. And between 0 and 2 pi, there are some places that have a sine value of -1. There's one place, and that angle is 3 pi over 2. And that's our only solution to this equation. In this next example, it's quadratic in form, but I have a sine of theta and a cosine squared theta. Since it's not all sines or not all cosines, I need to figure something out so that I can factor this. And what I can do is use a trig identity. Remember our Pythagorean identity, sine squared x plus cosine squared x equals 1. Since I have a cosine squared theta, I can rearrange this Pythagorean identity. Cosine squared x equals 1 minus sine squared x. So I can replace my cosine squared theta with 1 minus sine squared theta. So I get 1 plus sine theta equals 2, and then instead of cosine squared theta, 1 minus sine squared theta. And now I have an equation that has only sine thetas in it. And I'm going to distribute right here. 1 plus sine theta equals 2 minus 2 sine squared theta. And now I have a quadratic equation. I want to get everything to one side and solve by factoring. I'm going to move these two terms over to this side, so I have a positive sine squared theta. It's easier to factor, if you ask me. So I get positive 2 sine squared theta. And then we get plus sine theta. And then I have to subtract 2 from both sides to get this 2 over to the left side of the equation. And that gives us a minus 1 equals 0. Now I can solve this by factoring. So I need 2 sine theta times sine theta, and a 1 and a 1. And if I put a plus here and a minus here, that should work. And now I solve each equation. So my first is 2 sine theta minus 1 equals 0. Add 1 to both sides. 2 sine theta equals 1. Divide by 2. We get sine theta equals 1/2. And this time we are looking between 0 and 2 pi, so our whole unit circle. We need to think of all the places that have a sine value of positive 1/2, or a y-coordinate of positive 1/2, and that would be theta equals pi over 6, or 5 pi over 6. Now I solve the other side. Sine theta plus 1 equals 0, subtract 1. Sine theta equals negative 1, and that happens when theta is 3 pi over 2. So we get 3 solutions this time. In this last example, it's just another application of our inverse functions and trig functions. If we want to find the sine of tan inverse of v, first we start on the inside with tan inverse of v. That means we're trying to find some angle where we have a tangent value of v, and we could call that v over 1, which would be our y over our x. And if we make a triangle where we have an x coordinate of 1 and a y coordinate of v, and we use Pythagorean theorem to get an expression for r, 1 squared plus v squared equals r squared, square root both sides, and we get r equals the square root of 1 plus v squared. So that's an expression for r. And now I want to evaluate sine of this angle, theta, whatever it is. And the sine value would be the y over the r. So v over square root of 1 plus v squared. But of course I don't want to leave a radical in the denominator, so I multiply by square root of 1 plus v squared over the square root of 1 plus v squared, and we get v radical 1 plus v squared over 1 plus v squared. And there you go.